Today we are going to discuss on Codeforces round 611, division 3, and problem E. Its ranking is 1800. Little bit difficult, right? So let's introduce this problem by explaining the examples here, right? So here is the input. It has a number here. So the number 4 means the number of people and the number of houses in this problem. So for this case, there are 4 people, right? And 4 house. So we have 1, 2, 3, 4 house here. And the array here, the number in the array means the location of the person, right? So the first person is at the first house, and the second person is at the second house, and the third and the fourth person are both at the fourth house. So we have in house 1 we have 1 person, house 2 we have 1 person, and house 4 we have 2 people, right? So the output here is that the minimal number of house we can occupy, right? After we move some of the people here. So we need to move these people in a certain way, right? So for one person, for this person, we have 3 options. One is stay at the same place. One is move him to the left. And the third is to move him to the right, right? For this guy, we have 3 options. And also for this guy. So after the after the moving, we can what's the minimum number of houses we can occupy, and the second number in the output is the maximum number of houses we can occupy. So for this specific problem, um, the minimal house we can occupy is 2, right? So we move this guy here so that the second place has 2 people, and we keep this guy in place and keep these 2 guys in place. So we got 2 houses that are occupied. And what's the maximum number of houses we can occupy? It's 4, right? So we move one of the people in the 4th house to his left. So we got 4 houses occupied. So how to solve this problem? Um, First, we can count how many people in each houses, right? Then we can use a pointer, and we can move up the pointer from left to right, from the leftmost house to the rightmost house, right? So for each house, we can find out best strategy to move the people inside that house. So it's a greedy problem, right? Greedy means the we have a best option for each individual sub-problems, right? So we can explain it later. For now, let's just concentrate on the strategy here, right? So what's the strategy? So to get the minimal number of occupied house, we have a best strategy to move the people inside the first house. So there are 3 parts in the strategy. So the first thing we need to try is to find out if the house uh, to the left of the current house is empty. So in this case, it's empty, right? So we move all of these guys to its left. Actually, wait a minute. It's wrong, right? I'm so sorry for that. Actually, the strategy should be move all of those guys. Oh, actually, it's right. Sorry for the confusion. Let me start this over again. So the strategy to get the minimal number of occupied house is to first find out if the left house is occupied. So in this case, its left house is not occupied. So we cannot um, use this strategy. So we move to the second best strategy, right? So or stay if the current house is occupied. So actually, it's not because this guy is still outside of the house. We haven't placed this guy yet, so this house is not occupied. So the second strategy, we throw out the second strategy, right? So we try the third strategy. So we can move all these guys to its right. So we occupy this room, right? And we move on. We move the pointer to its right, right? So we now the pointer is pointed to the second house, and then we check out the first strategy again. So is this house occupied? The answer is no. So this strategy cannot cannot happen, right? So we try the second strategy. Is current house occupied? The answer is yes. It's already occupied by the first person, right? So we keep all these people in the second house at the same place. So in this way, the second house has two people, right? And we, because we already did the second strategy, so we don't need to try the third anymore, right? So let's go ahead and point to the third house. So there is no people in the third house, so we move on. So we have two people in the fourth house. So let's try the first. No, its left is not occupied. So we move on. Try the second. No, its current is not occupied. So we try the third. Yes, we move all of these guys to its right. Right? In this way, we got the minimum number of occupied house, which is 2. Right? So the why do we use this strategy? So the um, key point of this strategy is to occupy the houses that is already occupied, right? If the house is already occupied, we move the people there, right? So if we cannot find the occupied house for those people, we move them to the rightmost place, right? So let's take a look at the strategy to get the maximum number of occupied house. So the key point for this strategy is exactly the opposite of this one, right? So we want to spread the people as wide as possible, right? So let's still use the pointer to move from leftmost house to the rightmost, right? So for the leftmost house, let's check if its left is empty. Cool, its left is empty. So we move one person to its left house, right? So actually, we are going to write the number outside the room, right? So in this way, the people outside of the room are not placed yet, and we will place these guys into the rooms, right? So for the first house, we move this guy to its left, right? Because its left is empty, so we move him. And for the next one, its left is also empty, so we move him, right? And for the next, nobody here, so we move on. And for the next, there are two people here, so we move one to the left if its left is empty, right? So one is here. Then we try the second strategy. One stay if current is empty. So current is empty. So one of them stay here. So move one to the right. So we already place all of the people inside this house. So no more left anymore. We cannot pursue the third strategy, right? So let's try a more complicated um, example here. So we have 7 people. So we have 7 houses. 1, 2, 3, 4, 5, 6, 7, right? And there is one person in the first house, and 3 person at the third house, and 2 people at the fourth house, and 1 person at the seventh house, right? So let's use this exact same strategies to solve this case, right? So to get the minimum number of occupied house, we first we point to the first house and move all to left if left is occupied. It's not occupied, so we move on. Or stay if current is occupied. So it's not occupied, so we move on. Move all to the right, right? So we move all these guys to its right. Then point to here. Nobody here. So move on. Point to here. So 3 people here. And the left house is occupied. Cool. We move all 3 of them to its left. So we have 4 people here, right? And we move on. So left house is occupied. No, not occupied. So or stay if current is occupied, not occupied. So move to its right. So move these 2 guys to its right, right? Actually, there is only one person here, right? So for the last house, we do the same, right? Move everyone to its right. So in total, we have 3 house occupied. So the answer is 3. And let's try to solve the maximum problem. So as always, we start from the first house and move one to left if left is empty. Cool, we move this guy here. And no one left in the first house anymore. So we cannot pursue the second and the third strategy. So we skip them. And we move the pointer. Move to here, nobody here. Move here. Cool. So we start from the first strategy. Move one to its left. If left is empty, right? So one guy here. And no one stay if current is empty. So move one guy here, right? And move one to the right. If so, we move one more to the right. So we use up three of them. All of them move to a new place, right? And then we move the pointer. So we move to the fourth house and the two people in the fourth house. So we first move one to the left if left is empty. It's left is not empty, so we skip this strategy, right? And one stay if current is empty. So current is already occupied, so we skip this one as well. So move one to the right. Great. We move one to its right here, right? And there's still one left. Actually, we can move him wherever we want. It doesn't matter, right? Because all these three houses are already occupied. So it doesn't matter. And for the last guy, we move one to the left. His left is empty. So move him here. So in total, 1, 2, 3, 4, 5, 6 houses are occupied. So the final answer is 6, right? Whew, cool. That is all for our explanation of our strategies. So let's look at the code. So the code is pretty straightforward, right? So this is the counter. CNT is the counter to count how many people in a certain house. And these two array are the recorder of the state of the houses, right? So for the minimal number of occupied houses, uh, if O if OC minimal I minus 1 is true, that means we already place one person at I minus 1 location, right? And if it is false, it means that we don't have a person occupy that house, this house, right? And we iterate from the leftmost house to the rightmost house. And for the minimal number of occupied house, we check if the pointed house has um, has people. If it doesn't has any people, we don't need to do anything, right? So this part is just apply those strategies. And also for the maximum number of occupied house, we check all those three strategies. And before we apply each of the strategy, we need to check if we still have a person to place. If we don't have any person to place anymore, we cannot apply the next strategy, right? If we still have a person left, we can set the house occupied, and we need to decrease the number of people we got left, right? And we need to increase the number of maximum occupied houses. And after all this done, we output the answer, right? I guess that's it for today. Thank you for watching.